Okay, everybody. So what we're going to do is we're going to go over these midterm one practice problems for Math 4A. So I'm just going to write these out here on my iPad and record the audio, and then I'll be able to post a PDF for you and also the video. So if you're hearing this, you're at the video, but there should also be a PDF available. Okay, well, let's get right into it. So let's look at these true-false questions to start with. So when we start here, we've got if a limit from the right, So remember the plus sign means limit from the right. So we have a right-hand limit there. Then here we have a left-hand limit here. And those are supposed to be equal. And it says if those are equal, then the limit exists. The two-sided limit. And yes, that's the definition of when the two-sided limit exists. So this is true. Okay, so when the two one-sided limits exist and are equal, the two-sided limit exists. So true. Okay, next question. So the next question is similar but different, right? So we still have the right-hand limit here. We still have the left-hand limit here. And then it says f is continuous. So no, this is false. So if the right-hand limit equals the left-hand limit, that does not mean that the function is continuous. Because if you have a picture like the one I'm about to draw, what? No, I don't want a roller, go away. You can have this kind of picture right here. And I could put a dot up here or not. And in this case right here, the right-hand limit and the left-hand limit point you right at that hole, but then this is not a continuous function because the actual function value is up here. So to make this true, you would actually need this. If you had f of a equals the right-hand limit, which equals the left-hand limit, then it would be continuous. But without this, not continuous. Not necessarily continuous, right? So false. All right, next question. As x increases to 10, okay, f of x equals 1 over x gets closer to 0. That is true. So the limit as x goes to 10 of f of x is 0. No, that's not the case. So if you look at a picture of what this is saying, here's what it's saying. So as x increases to 10, and over here it says limit as x goes to 10. So we're looking at 10 on the x-axis. And it says as x increases to 10, f of x equals 1 over x gets closer to 0. That's true. That part's true because the function looks like this. Okay, that's what the function looks like. So if you are, let me get a better color for highlighting here. If you are here and you head this way, as you head towards 10, the function is going down. So it is getting closer to 0, right? But here it says, so it says that implies that the limit as x goes to 10 of f of x is 0. No. If you actually look at it, right, what is the limit as x goes to 10 of 1 over x, right? You can just plug in the x equals 10, right? There's no discontinuities there. So the limit's actually 1 over 10. But here it says it's 0, right? So right there, that's at 1 over 10. So there's no discontinuity, no divide by 0, nothing happening. You get closer to 0, the y value gets closer to 1/10, right? This limit right here. So what's that mean? It means this is false, right? Because it says the limit is 0, the limit is not 0. False. Okay. So this is kind of the opposite of, not the opposite, this is similar to B, but I think they give you everything that you need now. So here we have the function value g of 1 equals 6, and then we have the limit as x approaches 1 of g of x equals 6, and then g of x is continuous at x equals 1. Yeah, when the limit and the function value are equal, that's the definition of continuity. True. Right? That's what was missing. The function value is what was missing from B. Okay, so we got true, false, false, true. Okay. Then we have some average rates of change. So I'm not going to do these all in a whole lot of detail. Just grabbing a calculator, and I'm going to do kind of one of them, and then maybe we'll switch to a computer or something to do them a little bit faster. But grab the calculator, low battery, replace battery. No, just go. I will work until you die. Okay, so average rate of change. So the average rate of change for all of these, you have like a and you have a B, and then the formula for average rate of change is always going to be f of B minus f of A over B minus A. So when you do this for 2 and 2.1, right, f of 2.1 minus f of 2 over 2.1 minus 2 is going to be on the bottom 0.1. On the top, our function is here 1 over x squared. So f of 2.1 is 1 over 2.1 squared minus 1 over 2 squared, which is a quarter. And let's just punch this into a calculator, see what we get. 1 over 2.1 squared. I typed that in wrong. 1 over 2.1 squared minus 1 over 4 divided by 0.1. Delete. I get, see here, negative 0.232. Okay, now then we do the next one. I try to give myself a little more room. We've got f of 2.01 now minus f of 2 over 2.01 minus 2. So it's going to be 1 over 2.01 squared minus 1 over 2 squared over 0.01. So 1 over 2.01 squared minus 1 quarter divided by 0.01. I get negative 0.248. Just going to go 3 decimals there for now. Next one, I'll just go straight to this part. 1 over 2.001 squared minus 1 over 2 squared over 0.001. So punching this in. Oops. All right, what do we get? We get negative 0.2498. Just going over a little bit. One extra decimal point there. Okay, and then it says to guess the slope of the tangent line to the curve at x equals 2. So the idea there is you're going to be looking at the numbers that you got for the previous answers. So like negative 0.232, negative 0.248, negative 0.2498, and then we have to guess at the slope of the tangent line. Well, the slope of the tangent line is related to the slopes of the secant lines, right? These are secant lines. So what would I guess here? I think I would guess negative 0.25. That would be my guess. Does that make sense? These numbers are heading towards negative 2.5. That's what I think. Okay. Then we've got a question that says find the equation of the tangent line to the curve. And it says this won't be on the exam. It won't be on the exam, but we can do it. So if you're trying to find the equation of the tangent line, then you should start with, why won't it right? Okay. This is the point slope form of a line, if we remember, you need a point. What kind of point would we need? Well, we need an x value and we need a y value. So the x value they gave us for the point, right, here's my point. The x value is 2. I'm going to leave the y value blank for now. We need a slope. The slope is what we just found. I'm going to call it m equals negative 0.25. We need the y value. How do we get the y value? Well, this is at x equals 2, and the function up here is right here, right? So what is f of 2? It is 1 over 2 squared, so it is 1/4, or positive 0.25. So I'll put 0.25. That's the y value. So now we have everything we need to fill into our formula here. So y minus y1, the y value from the point is 0.25, equals m. M is negative 0.25. X minus x1, the x value is 2. So that's our equation. We can simplify it a little bit. So y minus 0.25 equals, here we can distribute this negative 0.25 in. So we're going to have negative 0.25x plus negative 0.25 times negative 2 is going to be positive 0.5, like that. And then we are going to move this negative 0.25 over to the other side, and we're going to get y equals negative 0.25 plus, x plus 0.75, right? Yep, so that should be it. And that's the equation of the tangent line, assuming we were right about our slope, right? Because we guessed at our slope. Next question. Okay, so this is like those tables for calculating limits. And there's not much to do. We're just going to plug these values into this function. So there's no secant line or tangent lines here. This is just a limit, right? Or we're trying to guess a limit. So in order to calculate f of 0.1, we're just going to go cosine 0.1 minus 1 over 0.1. And by the way, very important here, when you work this out, your calculator must be in radian mode, okay? Radian mode. If you are not in radian mode, you're not going to get the same answers that I get, and in fact, you're going to get the wrong answers, okay? So let's plug this in. So am I in radian mode? Let's check. Setup. My calculator, you can't see it. Stuck. Okay. Radian mode. Yep. Okay, good. So I've got cosine 0.1 minus 1, which is negative 0.004995 over 0.1. So I get, and I'll put this here, negative 0.04995. Okay, now we have to plug in 0.01. So we do that. So same formula that we're using here, we're just replacing this and this with 0.01. So we have cosine. I'll write out this one too, I guess. Cosine 0.01 minus 1 over 0.01. And we get negative 0.049995. Okay, next one. Same thing. I'm not even going to bother writing it. I'm just going to work it out. So we got cosine 0.001 minus 1 divided by 0.001. I get negative 0.00049999999. How many nines? I don't know. That's enough. All right. So what you want to notice here really is there's like 1 0. Oops, that's not what I wanted. There's like 1 0 here after the decimal point, and here there's 2 zeros after the decimal point, and here there's, how'd that happen? 3 zeros past the decimal point, right? So this is going down. It's getting closer and closer to 0 here. Let's put in some negative numbers, see how that looks. So we're going to have cosine negative 0.01. Nope, just 0.1 minus 1 over negative 0.1. So we work this out. And we get actually positive 0.049995. It's the same answer as up here, but this one's negative and the one down here is positive. And that's going to go for all of these. So I'm just going to fill them in. You can calculate them if you want. And again, what you want to notice is that there's 1, and then there's 2, and then there's 3. Okay. And so what's happening is as we get closer to 0, the actual values are going to 0 too, right? So they just get smaller and smaller. And they go towards 0. So it says guess the value for the limit, 0. Okay. All right. So that's it. I mean, I hope that makes sense, right? We did those in class. Evaluate the limits, either as numbers or plus or minus infinity here. These are designed to be done quickly here, okay? So you're not supposed to spend a lot of time and effort on these. That's why I put them in one problem here. So you're just supposed to do something like this. Like for the first one here, there's nothing that stops you from plugging in x equals 0 when we do this limit as x goes to 0. Right? We don't have all those divide by 0 issues here. So you just plug in 0. So you just go e to the 0 plus cosine 0, which is 1 plus 1, so it's 2. Okay, that's what you do. This one, again, there's nothing stopping you from just plugging in negative 4. So this is sine of pi times negative 4. I'll write it as negative 4 pi. If you don't know, every multiple of pi, sine of any multiple of pi is 0. Or, again, use a calculator. Next one. The next one, there actually is a trick, right? This is the kind where you have to factor. I just kind of threw that in. So, right, there's a divide by 0 if you plug in negative 2. So, just briefly factor the numerator into x minus 2x plus 2 over x plus 2. I forgot to write limit. Of course, the point is that you have an x plus 2 there and there. So this is the limit as x goes to negative 2 of just x minus 2. So you plug in negative 2, it's negative 2 minus 2, so it is negative 4. So, that's more work than the previous ones, but it's still not complicated. And this bottom one is, the exact same problem, just to make sure you understood what was going on. So, limit x goes to 3, factor the top, x minus 3, x plus 3, cancel, 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 cancel. We've got the limit as x goes to 3 of x plus 3, which is going to be 3 plus 3, which is 6. Okay, So the last two problems there were pretty much the same problem. All right, so problem 5 is where, in 6, this is where we've got quite a bit more complicated stuff to do, right? So these are our root type, fraction type limits and stuff. So let's go ahead and do this. So this first one is root type, right? Root. So we know, right, you can't just plug in 4 because you can get 4 minus 4, and the top will be 2 minus 2. So we gotta do what we call multiplying by the conjugate. So we're gonna multiply by root x plus 2 over root x plus 2, right? Same thing as this, but the sign is opposite. And the whole point of doing this, remember, is that whenever you do like an a minus b, like this, and an a plus b, you don't even have to think about it. You know the result is going to be a squared minus b squared. Actually, we just did the opposite of that up here, right? A squared minus b squared, and this is a minus b, a plus b. So I know that when I multiply this out, still have a limit here. Let me erase this, switch back to that color. So we know what's going to happen is you're going to get the a squared minus b squared, so you're going to get root x squared minus 2 squared on top. And if you remember what I told you to do in the denominator, what I told you to do in the denominator on these was not much. Like, don't simplify the denominator, just leave it like that. Now, you multiply that out in the numerator. So we got square root of x squared is x minus 2 squared, so that's minus 4. Then we have x minus 4 square root x plus 2. And the way this is designed to work is that the top should cancel with something in the denominator, like it just did, the x minus 4s. So you got 1 over square root x plus 2. Nothing is stopping you from plugging in x equals 4 now. So you do plug in x equals 4. You get 1 over square root 4 plus 2. So it's 1 over 2 plus 2, which is 1/4. Okay, so that's a root type. Then we have another root type. Right? So this is just for practice here. So another root type. So what we would do here is exactly the same thing on this one. So we're going to have square root 9 plus h plus 3. Square root 9 plus h plus 3. And when we multiply this out, as we know, right, like a, b, right? We know we're going to get a squared minus b squared when we multiply out the top. So it's going to be square root 9 plus h squared minus 3 squared. In the denominator, we're going to have h, and then square root 9 plus h plus 3. So, again, we are going to simplify that numerator. So when you square the square root of 9 plus h, you're going to get 9 plus h. And then we've got minus 3 squared, which is 9. In the denominator, don't do anything. Just keep writing it. So what happens in the numerator, I think is obvious. The 9's cancel. Then you've got an h up there. You've got an h in the denominator as well. So since we've got an h in the denominator and the numerator, we should cancel that. And I'm going to kind of combine steps and just jump to what we're doing next here. Once the h is canceled, you can go ahead and you can plug in your h equals 0. So we have 1 over square root 9 plus 0 plus 3. So this is going to be 1 over square root 9 is 3. So this is 3 plus 3. So 1/6. Okay. And again, the work was the same as the previous one. It just looked a little different because of the h's. All right. Next question. Evaluate the limit either as numbers or plus or minus infinity. Okay, so these are fraction type, right? At least this one is. So fraction type. So what we do is we look for the common denominator, right? So on this one, the common denominator is 3x, right? Because we have the x and we have the 3. So what I do on these is I multiply every term by the common denominator. So 3x, 3x. Same thing in the denominator, 3x, 3x. Everything gets a 3x. So what's that going to look like when we multiply it out? So the point is that a lot of them cancel. I'll just highlight the ones that cancel, right? So that x is canceling with that x. So it's only going to leave you with the 3 times the 2. Let me write my limit. So you're going to be left with the 3 and the 2, which is 6. Over here, the 3 will cancel with the 3, and will leave you with the 2 and the x. So minus 2 times x. In the denominator, we've got 3 times x, which is 3x squared. And then we have 3 times x, which is 9x. So minus 9x. Like that. Give me a second here. Just looking at this for a minute. 3 times 2 is 6. The 3 is canceled, minus 2x. Okay. All right, okay. All right, so from here we need to cancel some stuff. In order to cancel some stuff, we're going to have to factor some stuff out of the denominator. So you look down here and you realize that these both have a 3 and they both have an x, right? So we can factor out a 3x. Now you might be saying like, of course we can factor out a 3x. We just multiplied in the 3x. Okay, fair enough. But I multiplied it in, so now I have to unmultiply it in. So we're going to go ahead and take out that 3x. And if I do, what I'm going to be left with there is if I take away 3x down here, I'm going to have just an x left, right? And if I take away the 3x here, I'm going to have just a 3 left, so minus 3. Basically, I'm back to what I started with, right? X minus 3, and then times 3x. In the numerator, I realized that these both have a 2 in common, so I take out a 2. Okay, I take out a 2, and I will be left with 3 minus x, right? 2 times 3 is 6, and 2 times x is 2x. Now, at some point, you realize that you've almost got the same thing, 3 minus x, x minus 3, but they're not the right way around. So there was a way that we handled this. The way that we handled it was we knew that if you got like an a minus b kind of thing, you need to reverse the order. It would be equal to negative b minus a. So you can switch the order and add a minus out front. So we'll do that here. So we're going to get a limit x to 3. I'm going to take out a negative, so negative 2, and then I'll have x minus 3. Right? The order is reversed and we have a negative. Bottom, just write it. So at that point, we've got an x minus 3 on top and an x minus 3 on bottom. Cancel, cancel. So we have a limit as x goes to 3 of -2 over 3x. Well, nothing is stopping me from plugging in my x equals 3 anymore, so I do. So I'm going to get -2 over 3 times 3, so -2 divided by 9. And there we go. So that limit exists. And one more. So this is going to be probably the trickiest one that we look at. It's fraction type, so we're still basically doing the same thing. So our common denominator is going to be 5 plus h times 5, right? So again, we multiply every term by that. So we're going to take that first term, multiply by 5 plus h, 5. Second one, 5 plus h, 5. And and also the denominator, 5 plus h, 5. Okay, everything gets a 5 plus h, 5. Let's cancel. Oops. So I'll cancel. I'll just cross them out this time like I didn't last time. I don't know why. So that first term, the 5 plus h, is going to cancel with the 5 plus h. On the second one, the 5 is going to cancel with the 5. So what will we end up with? Let's see. A limit as h goes to 0. On top, we just have the 5 times the 1, which is just 5 minus. Then we have minus 1 times 5 plus h, right? The denominator is gone, so just minus 5 plus h. Just be careful not to lose your parentheses there, and you'll be okay. In the denominator, we have h, 5 plus h, 5. Okay. Now, you might be tempted here to do this. You might see the 5 plus h and go cancel, cancel. That's not valid. That's not valid because this 5 plus h is not factored out of the numerator, so you can't cancel it that way. It's not a factor of the numerator, so you can't cancel factors. What you actually have to do, back that up, is you're going to actually have to multiply out this, or actually just distribute the minus sign here and simplify the numerator. Okay, so limit h to 0, we've got 5 and then minus 5 and then minus h. And we're doing nothing to the denominator. So 5's cancel. So the 5's cancel. So we have a limit as h goes to 0 of negative h over h, 5 plus h, 5. And actually, it is the h that cancels. So as soon as we do that, there's nothing from stopping us from plugging in h equals 0 now. I'll kind of cheat and do it in one line again. So in the numerator, we just have -1, right? We canceled the h, but the negative is still there. And then we're going to plug in h equals 0 down here. So we're going to have 5 plus 0 and 5. So we end up with -1 over 5 times 5, which is 25. All right, there we go. So 2 root type, 2 fraction types, a little bit tricky, but you can do them with practice. And now we just have a bunch of hopefully easy questions on a graph. Really make sure you know how to do this, right? Like these should be free points on an exam for you. So make sure you know left from right and that kind of thing. All right, so let's start here. X goes to 2 from the left, right? This is left. So we're doing this. So where do we end up? We end up right here as we approach 2 from the left. And what's that y value? Well, it's right here, right? This is 3, so it's 1, 2, 3. So this is at a y value of 1. 1. All right. Next one is x goes to 2 from the right. So that's the right-hand side. So we end up here, which is at a y value of 2. So that one's 2. Then it says, does the limit as x goes to 2 of f of x exist? Why or why not? Answer is no. And the reason why is because the two one-sided limits, the answers up here, are not equal, right? So we just say limit x goes to 2 from the right is not equal. I don't know why I'm writing it in this much detail. To limit as x goes to 2 from the left. You could just say, left-hand limit and right-hand limit don't agree, or something like that. Of course, no is the most important part there. Is f of x continuous? No, right? The definition of continuity says that the function value is equal to the limit and there's no limit, right? So f of 2 is not equal to the limit as x goes to 2 of f of x because this doesn't even exist. Okay, so no, not continuous. All right, more of these. Now we're going 0. 0 from the left, 0 from the right, two-handed limit. Where is 0? 0 is, we're talking about the x value of 0. So when you do the limit from the left, that's this. And when you do the limit from the right, that's this. And in both cases, from the left and from the right, you end up right here, right, at 3, at a y value of 3. So when you do this, limit from the left was 3. The limit from the right is 3. Does the two-sided limit exist? Yes. It's 3. If these two are equal, then it's this one. I'm not going to write that. Is f of x continuous at x equals 0? Yeah. Yes. Because f of 0 is also 3, right? If you were to look at this graph, you'd go to 0, you'd go up here, right here at 3. F of 0 equals 3, which is also equal to the limit as x goes to 0 of f of x. So yes, it is continuous. Okay. Is that it? Is that all I put on here? Short practice test. You guys are getting off easy. Okay, so I guess that's it. So I will upload this now, stop the video, and, good luck studying.